Here's a project called River Crossing. It's in Tyngsboro, Mass. There's a couple of wells that pump into a well house at the bottom of a hill down by a river. The water flows up the hill, through a roadway, and into this little booster pit. That's got a couple booster pumps in there as well that boost the pressure, and it pumps the water, the drinking water, out into four apartment buildings. So there are lines that feed each apartment building. So part of the problem is that this is such a remote location, it's very difficult to get to, and they have to lug jugs of potassium hydroxide for treatment down here, and the system is very tiny and dilapidated, and it's in need of an upgrade. So what our plan is to do is to remove all the treatment in this little well house, and the water is still going to flow through these two lines, and what we're going to do is connect one new line into these two existing lines, bring that into this building. The water is going to come out of the building, go into this storage tank. Then there's a line that comes out of the storage tank, and there are two pumps in here that are going to pump the water back into the building and out the second line and back into the two original lines and continue to feed the rest of the development. So what we're looking at here is a little bit of a blow up of the location where we're going to make the connection to those lines. So we're going to tie into these two lines, run a new underground line into this pump station building. This is a 16 by 24 inch building with a 24 by 24 garage next to it. Inside this building, the water is going to be treated, and the water is going to flow out into the storage tank, and like I said, out of these two booster pumps and back into this building. And then once the water comes out of this building, the new line will connect back into these two original lines and go off and feed the rest of the development. This is a schematic of the pump station building. You got the 24 dimension this way, 16 feet this way. The garage is on this side. We got a couple of doors that are going to allow access here. And what we have is the water supply line is going to come in from the street, from those two lines that we connected to. Is going to come up through the floor and come around the side here. We're going to inject potassium hydroxide, that's KOH, and the water is going to go through this contact tank for mixing, and then down through the floor and basically out under the floor and over into the storage tank. Now what we have here is a bulk potassium hydroxide tank, and this is very caustic chemical, so we built a little 12-inch tall concrete berm on the floor in case any of this chemical spills. It's going to be contained in the concrete containment area. We have an outside fill port on the outside of the wall with a little locking door so the truck can come and fill up this potassium hydroxide tank. Then we got a pipe that comes out of the bottom of that tank that goes into a transfer pump. It's activated by a manual switch that transfers the potassium hydroxide into this day tank. It's a potassium hydroxide day tank. On top of that day tank, there's a little chemical feed pump that pumps the potassium hydroxide into this copper piping, which mixes it with the drinking water. So after the water comes out of the tank, there are two booster pumps that draw the water from the storage tank, and those lines come in here and here, and they come up through the floor. They connect together, go through a flow meter, and basically punch back down through the floor, go underground out here, and back out to connect into the rest of the distribution system. Now the treated water has a branch that comes off of it, and a small amount of water runs through what they call a pH analyzer, and that's continuously monitoring the pH of the water. So that flow has to continuously let water flow through to monitor the pH. So in order to dispose of that water, there's a pipe that goes down through the floor and goes outside. It also collects some floor drains in here, and it goes out through the wall and goes over to a outside leach pit. So that drain line is shown on this plan, comes out of the pump station, then it comes down and flows along here and goes into these 8 underground plastic leaching chambers. This is a leach pit that disposes of that water. We've oversized this a little bit bigger in case we ever needed to put treatment, so we could actually put backwash water in here if necessary. The other thing under here is this dash line is a perforated pipe underneath the storage tank, and that has a connection to a solid pipe that daylights down the bottom of the hill, so any groundwater that tries to come up below the storage tank gets captured in this pipe and relieved in here. If you don't relieve groundwater, it's actually possible that this big concrete tank could even float if it was ever drawn down when it's close to being empty. This detail shows what the plastic chambers look like. They're basically 3 feet wide, so 2 of them together are about 6 feet wide, and they're 6 feet long, so 4 of them is 24 feet. They're plastic and they got louvers on the side that allow the water to drain out. Another detail that's important to look at is this is the edge of the storage tank. We have a pipe that comes out the bottom. It's got a couple of holes on the top so the water seeps into the top of the pipe. The water level in the storage tank is usually up high, only a foot or 2 down from the ceiling. So water is always flooded in this suction line here. Then we have basically what looks like from the surface are just 2 wells with well cap, but they're actually not wells. They have a cover on the bottom of the pipe, so the water flows out of here, goes into the screen of a submersible pump, and that submersible pump, there's 2 of them, pump the water out through here, and this is the 2 lines that go back into the pump station. This is a detail of an underground concrete storage tank. It's about 54.8 feet long, and the cross section is 10 feet wide by 8 feet tall on the interior. There's an access way to allow access into here with a ladder. We got an overflow pipe in case the tank ever fills up too high. We've got underground lines. That's the underground line that goes to the suction pumps that I just showed you. We got a vent to allow air to escape and replenish when the tank level goes up and down. And this is the fill line that comes in through the sidewall from the pump station. And again, you can see the crushed stone base, and there's an under drain in here, and that's what alleviates the groundwater. It's got an access hatch on top that doesn't allow any kind of penetration of any bugs or rodents or anything like that. So again, looking at the overall site, what this allows us to do is to eliminate all the treatment down here at the bottom of the hill in this well house, which didn't even have an access road to get to. So the operator had to lug jugs of this potassium hydroxide down there. So now that treatment's all gone from there, and the raw water, like I said before, gets pumped up through these 2 lines. And now we treat the water in the pump station here, store the treated water in the storage tank, and repump the treated water through the pump station again and through these 2 lines. And now we're able to get rid of the booster pumps, because these pumps in the wet wells are now provide enough pressure that we can get rid of the booster pumps in here. So what this also allows us to do is we always have, 30,000 gallons of treated stored water on hand. So if something happens to one of the well pumps over here, we don't have to worry about running out of water right away. We can have time to react to get to fix the well pumps. We always have these 2 booster pumps online, and there are 2 of them in case one of those fails. This is the second one that's operational. So we have stored water, and we have constant pressure being provided to all of these buildings. So the rest of the videos are going to show you the construction.